Okay, so for macromolecules, right, when we look at macromolecules, we are looking at very, very large molecules. How large is large is we are looking at maybe 10, 20, 30 molecules, and how we actually see it is it usually is represented with a bracket and an n and a subscript n at the bottom to represent the number of times the molecules actually repeat. Okay, and there's two ways to actually create the molecules. It's either through addition polymerization or condensation polymerization. So over here we take a look for macromolecules, the polymers, right? So a macromolecule is a very large molecule that is made up of many small molecules, and each of these polymer is a type of long chain macromolecule that is covalently linked together by many small repeated units, which we call monomers. So these different polymers, they tend to have makeup of many different types of different monomers. So mono means made up of one molecule, poly means a lot. So what are some examples of polymers? There is two types. We have the natural and we also have the synthetic. Natural means we create by itself. That means it occurs naturally from the environment, not humanly created. Synthetic means you create using humans, like using chemical or lab. So we could see that protein, starch, all these are mainly found in food substances. Whereas for synthetic, we tend to actually look at plastics and things like this. So polymerization, right, is the process in which you actually join large number of monomers into a single polymer. And there is two ways to go about doing it. It's either through addition polymerization or condensation polymerization. Addition polymerization, like the name suggests, means you keep adding new molecule. Okay. Condensation polymerization means that you actually use water. Okay. So addition polymerization occurs when the monomers just tends to join together without losing any forms of molecules or atoms. So this one, the only one that usually does this is you use an alkene molecule. And it can undergo addition polymerization. Some of the conditions they tend to have is high pressure and of course at high temperature. So these two conditions must meet in order for alkenes to undergo addition polymerization. And of course you use a catalyst to speed up the reaction. So for carbon-carbon double bond of the ethene molecules, the monomers will tend to actually break up. So break in the form of the carbon bond here. So one of the bonds will actually break. So this one, when the bonds actually are being broken or overcome, it will then leave each carbon to have another extra single bond to be formed. And what will happen, this single bond will then be joined with the other neighboring monomers to form single bonds so that you can have things like this. And if we were to draw this line, you'll be able to see the repeated units. This is one repeated unit, this is another repeated unit, another one here. So you can see 4 repeated units. Unit 1, 2, 3, and 4. 4 repeated units. And on top of these 4 repeated units, right, you realize that it actually carries other items as well. Other ways to write it, which is like this. This is how you can do it. Okay. So for equation for polymerization, your ethene can actually undergo addition polymerization to form polyethene at high temperature, pressure, and the use of catalyst. So you could see that the word poly is inserted in front with the bracket. So this refers to all the ethene molecules. So these can undergo also at high temperature and pressure to form this. So there are many different ways to represent it, either the word equation or the full structural formula equation. Okay? And do take note that we usually write the repeated units inside and we bracket it with the bracket n. to show that this one has an infinite number lah. So repeated unit, we tend to actually draw this without the bracket. So in exam, you must be very clear lah. Do they want repeated unit or do they want polymer? Polymer, you have to write the y at the end. Repeated unit, no need the n. Okay? And the n usually represents a very large number. So next we see that PVA, okay, is also used as a main constitution in your emulsion in paints. And how do we actually see the repeated unit? We spot the pattern, and you realize that this is, when we split here, this is one repeated unit, this is two repeated unit. And next, how you actually draw the repeated unit, right, is you actually erase where the lines repeat. So for example, in this case, okay, I would say this is the one, so I erase it. Then I will erase the other side of the line. And after I erase, I just draw a double bond in between the carbon. And this represents the monomer used for the whole polymer just now you saw. Okay? So you can see, identify the repeating unit first, and after you have identify the repeating unit, you remove the single bond. Okay, or you can just draw and then you remove the side single bonds to convert the inner middle line here to represent the single bond between the carbon-carbon bond. So you get this. So next we look at what are some of the uses. So polyethylene, right, you can actually use it for molding into different shapes because it's actually plastic, and you can use it to form toys, your plastic bags, or even to form beer buckets. Other addition polymers, you can have polystyrene. This is hard, light, and brittle, and this is usually used to make disposable containers. Your PVC, okay, is also used to make your pipes, raincoats, flooring mats. So this one is more of like to give you a waterproof kind of feature. Okay, and then next is addition polymers. They are actually very good insulators of heat and electricity, and are very resistant to any form of chemical attacks. So they are they are both flexible, and yet it's also very durable and hardy in a sense. So we have already talked about addition polymerization that involves mainly your alkenes. What about the rest? We look at condensation reaction, and for condensation reaction, right, this occurs when the monomers will actually combine with the removal of a small molecule, and this small molecule is actually water. So when it comes to water, right, we look at H2O lah. We could see that there is easily one or two compounds that are usually involved that has the OH group already, and that is your alcohol and carboxylic acid. So what will happen is for condensation polymerization, right, these polymers, they are made by two different types of monomers, and each of it has its own individual functional group. Meaning, right, the functional group must exist at both ends of the monomer in order for it to keep on to lose the water and to also form continuously. If it's just like one side, like just now the alcohols and carboxylic acids that we have went through one side, right, you cannot always continuously extend the molecule because it has no more extra hydroxide group to release already. So what are some of the functional groups we are looking at in your syllabus? There is two. One is polyesters, the other is polyamides. Polyamides are those that has the NH3 groups as well as your carboxylic acid groups. So like protein are some examples. Okay, so let's say we look at nylon. So for nylon, you could see that they have their one function. This is one type of functional group, but you see that both ends must have the functional group for the monomer, and the other monomer will have another functional group. So what happens is, because of the loss of water, you would see that this will come out to form water. freeing up the bonds between them. So when it frees up, right, what you'll realize is it will actually form a bond like this. Okay. And of course this bond will actually be repeated throughout. So when we look at this, this is how the two monomers will be reacted, where you actually remove the NH, the NH bond, mainly is the hydrogen bonds between them, and the OH. And what will happen is this will actually form the water, and you will see a lot of all these amide linkages. So in exam, you might be required to indicate where are the amide linkages, or to draw it out. So if you draw it in this way, nothing wrong lah. But the thing is very clustered. So actually, to be honest, this is the more appropriate way to draw. Then you don't have to continue to extend it. Over here, you cannot draw an end. Then you break, like you draw this end here. This is wrong because this is not a repeated unit. Okay, it must be similar. So the monomers, they are joined together by your amide linkages. That's why you call it a polyamide, because it has multiple amide linkages. Okay, so repeated units and functional group of nylon, they tend to be something like this. And then nylon is what we call a polyamide, as it contains many amide linkages, which is this. Okay. In another example is your toluene, which is a synthetic polyester, and this is made from these monomers, your diol. Diol are basically alcohols or compounds with two hydroxide group at the end. And dicarboxylic acid is this one. So again, you will want to lose the water. Okay, just like how you lose the water here. You see? So this one will come out, this one will come out, form water. Then you will join to form a ester linkage, because these are your esters linkage. Your C, double bond O, O, and this is maybe a C or something like that. But more importantly is this group, the C double bond O, O. This will represent the ester linkage, and because it has a lot of esters, this is the name of the compound formula. So this repeated use, you could see that the repeated use again, this is the bonds that is actually attached, the ester linkage, and that repeated units are what we call polyesters lah, so on and so forth. Okay, to combine this whole thing, you can actually bracket apple and N also at the end. So synthetic, so some of these use of man-made fibers, right, they are synthetic in order to actually manufacture. Most of it usually is plastic lah, which then can be spin into threads, like small threads for either forming even longer other items like your raincoats and what's not. Okay, and that nylon and toluene are still the best known examples of synthetic fibers. Clothes can also be made from these fibers, as they are string proof and are crease proof, meaning right, they won't crumple, forming like lines and things like this, and they are easily to wash because they tend to be waterproof. Okay, examples of items made from nylon and toluene is your curtains, parachutes, fishing lines, and sleeping bags. So like fishing line actually is made of mainly nylon string, and when it's actually being thrown, it's actually very durable and won't snap easily. Your guitar is also, some of it also use nylons, because when you strum, right, it's able to vibrate very tight, long lah. So that one is when you actually tighten the nylon string. Then finally, because we are always making plastic, there is always the inevitable pollution. So advantage of using plastic, so plastics, they are increasingly being used in place of your natural materials such as your wood, metal, cotton and leather. And generally, why do we want to use plastic? It's because they are cheap, relatively cheap, and you can easily mold it into different shapes, very flexible. Okay, they are also light and tough and waterproof and durable. The only bad thing about this is that they are non-biodegradable. in the sense they cannot actually degrade over time naturally lah. So what we do is we have to we usually throw it away, and by throwing it away it's like we contribute to land pollution, where plastics are generally non-biodegradable and are actually not able to decompose by bacteria in the soil. So this will also lead to a lot of build-up of waste, and that's actually quite bad to our environment. And plastics, they are also flammable, but when you burn plastic you actually produce a poisonous fume. So burning is also not the best way to dispose plastic. Okay. Then water pollution, if because they are non-biodegradable, the plastic that you throw will remain always in the ocean bed lah. And sometimes right, when marine animals actually go in and eat all this plastic, they tend to actually accumulate in the stomach, because this cannot be decomposed and eventually they can die off naturally. Because for some marine animals, they don't really know how to differentiate what can eat and what cannot eat. Okay. So how can we properly dispose plastic? Because most of them, when we burn, they produce poisonous gas, right? So what we want to do is we tend to recycle. So burning plastics will therefore cause air pollution, and the best way to deal with it is to reuse it or to recycle it, or we use lesser of it. Okay, so that's generally the end of this macromolecules chapter.